Alright, using n behaviors, turning points and zeros to match each polynomial equation with the most likely graph below and explain. Alright, so we want to match each of these equations with a potential sketch. Now, I'm just going to write some characteristics for each of them. So part A here, for this function, y is equal to 2x cubed minus 4x squared plus 3x plus 2. This is an odd degree function, right? And it's also positive, so it's a positive odd degree function, so we should say that the n behaviors should be found in quadrants 3 and quadrants 1, right? So it's a positive odd degree function because the leading coefficient here is 2. And this tells us that we should also have opposite n behaviors. And furthermore, we should also see turns. You should also always see n minus 1. So in this case, you should see a maximum of 2 turns. Okay, so let's take a look at part B. I'm just going to write some characteristics of each and then we'll match it up with the original graphs, right? So this is, we can see that the degree here is 4, n is 4, so this is a negative even degree function. So if it's a negative even degree function, the n behaviors here should be found in quadrants 3 and quadrants 4. And the number of turns you should expect here in maximum is basically 3. Okay, let's take a look at part C. So part C here, we're looking at y is equal to x squared plus 3x minus 5, right? So the degree here, n is equal to 2, it's a quadratic, so the number of turns here, you should only have 1 turn, right? And this is also a positive even degree function. So if it's a positive even degree function, the n behavior should be found in quadrants 1 and quadrants 2. Okay, part D, we have y is equal to x to the power 4 minus x cubed minus 4x squared plus 5x, right? So you can see that the degree here is 4. The number of turns here, the max of turns you should get is 3. This is also a positive even degree function because the a value, the leading coefficient, is basically 1, right? And the n behaviors would be found in quadrants 1 and quadrants 2. Okay, let's take a look at part E. Right, so in this case, the degree here, n is equal to 5. If n is equal to 5, this is basically a negative odd degree. It's a negative odd degree function. So if it's a negative odd degree function, then we can imagine that the n behaviors here should be in quadrants 2 and quadrants 4. Okay, so quadrants 2 and quadrants 4, and the number of turns you should expect are 4 in max, right? So in maximum you should only see 4 turns. And part F here we should see this is n is equal to 3. It's a cubic function, right? The n behaviors should be in quadrants 3 and quadrants 1, right? And this is basically a positive odd degree function. You should see a max of 2 turns. Excuse me. Okay, so let's figure out what each of these, so looking at all these characteristics, what are some potential sketches for each? Well, I'm going to start with part A here. We have 2 turns, n behavior should be in quadrants 3 and 1. I think the best scenario for that would, and it's a positive odd degree function, right? So I'd say this was B. Okay, so the best scenario for that, this is B. So that's off the chopping block, right? Okay, so the next thing we need to look at here is we also have so part B, there is a degree of 4, there's 3 turns, and the n behavior is a negative even degree function, so both should be facing into negative infinity in quadrant 3 and 4. So I think the only scenario for that is part A. Okay, let's take a look at C here. It's n is equal to 2, there's 1 turn, it's a positive even degree function, so you should see it in quadrant 1 and 2. There should only be 1 turn, however. The only scenario in that case would be E, right, because both of them are positive infinity, and there's only one term. Let's take a look at D here. There is 3 terms, n is equal to 4, positive even degree function, quadrants 1 and 2. Well, that's the only scenario for that is basically part C. Let's take a look at E here. This guy actually has 4 terms, and it's a negative odd degree function, quadrants 2 and 4. Well, the only scenario for that case is F, right? So this is F, and whoops. And then the last case here, this the only one left is basically D, right? So this was part F here. And in this case, you can see that it's basically positive odd degree function. And the way you can differentiate between D and B, right? You'd have to look at intercepts basically, right? So the only way to really look at it is through intercepts. But in this case, this would be D, because this would basically be odd, opposite, n behaviors, and it looks like, you know, there's 2 terms as well, right? So it is a little tough looking at these two. To be honest, I would probably go with, well, this is quadrants. We said this was, what did we say was B? Part A? Yeah, to be honest, I would probably go with, this is, I would probably switch these two, B and D, just because for, just for A, this is the point is 0 and 2, and this is 0 and 1, right? So it looks like this was lower down than this guy, right? It's kind of hard to tell. You need a more refined sketch, right? So I would probably switch these two because of the y-intercept, right? So this would basically be D, and then this would be A, I believe, B. Okay, just because the y-intercept here is 0 and 1, and the y-intercept here was 0 and 2. Okay, but other than that, everything else will suffice.